Welcome to part 2 of the video on the chain rule. In this video we're going to learn how to solve problems using the chain rule. Okay, let's remember what the chain rule says. Given a function, a composite function h of x, that is a composition of f and g, the chain rule says that the derivative of h is f prime g of x times g prime of x. So there is a very useful way of thinking about the chain rule. That, well, you can think of f as the outer function and think of g as the inner function. For example, let's consider this function again. We found the derivative of this function in part 1. But let's think in terms of outer function and inner function. Here the outer function will be sine, the function that takes the sine of a number, and the inner function will be x squared. That is, the sine is the outer function and the x squared is the inner function. So in this, with this notation, the outer function will be the function f and the inner function will be g. So what the chain rule says using outer and inner function terminology is that you should take the derivative of the outer function, evaluate it at g of x, and then multiply that by the derivative of the inner function. So for this example we have the outer function is sine, so the derivative of that is cosine, and we evaluated it at g of x, that is x squared, so we get cosine of x squared, and then we multiply by the derivative of the inner function. The inner function is x squared, so its derivative is 2x. So we have that cosine is the derivative of the outer function and 2x is the derivative of the inner function. We're going to solve some examples using this method or this way of looking at the chain rule. Here we have the square root of the sine of x. So always when you have a square root, it is useful to write it as an exponent. This is useful when you want to find derivatives. So we can write this like this. And here we have the inner function is sine of x, and the outer function is the function that takes the square root. Well, okay, so the first thing we need to do is to take the derivative of the outer function, and when you do that, you may forget what is the inner function. You may think of the inner function just as a variable. In this case we're going to use the letter y. So to take the derivative of the outer function, you just take the derivative, you don't worry about the inner function. So taking the derivative of this, we have that this is 3 times 1/2 times y to the minus 1/2. But the chain rule says that then you need to multiply by the derivative of the inner function, and the inner function is sine of x. So the derivative of sine of x is cosine of x. So we apply the chain rule and we got this. We can write this as cosine of x over the square root of sine of x. I forgot here to put the number 2. Here we have a similar example, but here inside the square root we have sine of 2x, and sine of 2x is a composite function again. We write the square root as an exponent, and now we can take the derivative. The derivative of the outer function, we forget about the inner function and take the derivative. That is a times 1/2 times the inner function to the minus 1/2. Now we multiply that by the derivative of the inner function. But the inner function is a composite function, so we need to apply the chain rule. In this case the outer function is sine and the inner function is 2x. So this derivative is cosine of 2x, that is the derivative of the outer function, times 2. 2 is the derivative of the inner function, that is 2x. So here we can cancel this the number 2, and we get this expression. That's the final answer. So in this video we saw some examples of how to apply the chain rule. In future videos we may solve even more complex examples. So that's all for now. Thank you for watching and see you next time.